Okay, so this is 11.2, circles 2. Again, I know you can't see that very well, so look at the pictures in the book. But hopefully this will give you a little help walk through so you know what's what. So for this one, we're looking at some new things. We've got a thing called a chord, which goes from one side to the other, and that chord creates a segment. Okay? It's the same word that you use in a chord on a guitar. In this case, it's something that goes from one side to the other of a circle and creates what we call a segment. Then we've got a sector, which is a different sort of shape, and that's created by two radii. What radius is? Two radii. That's RADII. That sector, created there by those two, say, radii. What goes around that bit there is the arc, which is a part of the circumference. So these are the new ones we're going to have to work out, and we have to use the formulas from circles 1. We could work out that area of the whole circle by doing pi r squared. If we know the angle here, which we're going to call theta, that one that looks like a kidney bean, if we know that angle, we can work out a fraction of the whole circle. How many degrees in the whole circle? Yes, 360, well done. So if we know the angle there, we can do the angle of that sector divided by 360, which will give me the fraction of the circle that I've got. If you imagine you had a semicircle, that angle there would be 180. 180 divided by 360 would be a half. So a semicircle is half a circle. You can see that sort of theory follows through. Similarly, if I had a quarter of a circle, made by 2 radii, remember this diameter is 2 radii. If I had this one, which is a quarter of a circle, 2 radii, making this sector 90 degrees, 90 divided by 360 is a quarter. That's a quarter of the area of the circle. You work out the whole area of the circle times by a quarter. If you want to know the arc length, it's the same idea. If I know the fraction of this circle that I've got here, I multiply pi times the diameter, which is the whole circumference, by the fraction of the circle I've got. Again, those two examples to prove that idea. You have a semicircle, half of it, we have half the circumference. 180 divided by 360 is a half. On a quarter of a circle, I'd have 90 degrees. 90 divided by 360 is a quarter. A quarter of the whole circumference will give you that one there. Okay, so that's arc length of a sector and the sector area, just by working out fractions of the formulas I use in circles 1. Okay, segments are a bit trickier because how can you work out what fraction they are? Well, you can't really, so what we have to do is to create a sector. We're using these ideas to help us. The segment is that bit there. I can work out the area of the whole sector using this theory. I know this angle. And then I can take away the area of this triangle to give me the area that's left, which is that coloured in bit, which is that segment. So 5A and B are a good example of this in 11.2S. First of all, A asks you to work out the area of the sector, which is a good clue because that's where you have to start. I can work that out because it tells me this is 130 degrees. I've drawn it a lot smaller than that, but it tells you in the book it's 130 degrees. So I use this idea, 130 divided by 360, multiplied by pi r squared to get the area of that whole sector. You can work it out, it's in the back of the book, and it comes out to be 1,240 millimetre squares, 3 significant figures. When you've got that, you then need to work out the area of this triangle. If you take the area of this triangle away from the area of the whole sector, you'll be left with a segment. They tell you in the book that this is 14 and this is 33. But the length I actually need to work out the area is the 14 and this area of the base of the triangle. So if we go back to previous work we've done, I'm sure you're all thinking, oh, I can work that out. So if I've got two sides of a triangle, I can use, yes, well done, George, you can use Pythagoras. So I can use Pythagoras, 33 squared, take away 14 squared, will give me what this one squared is. Obviously, when I've got what that is, squared, square root to find that length. When you've got this length, obviously you go double it, so you get the whole of the base of this triangle, and then we do the base times the height and divide by 2, because remember the area of a triangle is a half the base times the height. So I've worked this out using my Pythagoras to get that one, doubled it so I know all of it, times by 14, and half of that. That will give me the area of this triangle, so I'll then need to do 1,240, take away the area of that triangle, and that will give me the area that's left for the segment.